In this example, we're going to continue to use the grouping number method to factor some trinomials. We've got 7x squared minus 5x minus 18. So we're going to take our multiplication right here. In this case, we would take 7 times negative 18, which gives us the product of negative 126. And we need to find a pair that multiplies to give us negative 126, but adds up to negative 5. We would find eventually by going through certain pairs that negative 14 and positive 9 is the pair that we want, and so we're going to split up our polynomial's middle term. We're going to have 7x squared minus 14x plus 9x minus 18. And we factor by grouping here, which means that we take in our first pair 7x squared minus 14x and factor out the greatest common factor of those two, which is 7x, leaving us with x. 7x times x is x squared, minus 2, because 7x times 2 is 14x. And in the second pair, we can factor out a positive 9 and say positive 9 times x gives us positive 9x, and positive 9 times negative 2 gives us negative 18. Our common binomial factor is now x minus 2, leaving us with 7x plus 9, and so our factorization is complete. In the second pair, our leading coefficient is 9. Our constant at the end is positive 4, giving us positive 36. And the pair of numbers that multiplies to give us 36 but adds to negative 13 happens to be negative 9 and negative 4. So we're going to split up our middle term using negative 9 and negative 4. Only this time I'm going to reverse the way I've written it here on the side. I'm going to say, well, let's take 9y squared minus 4y minus 9y plus 4. And the purpose of this illustration is to show you that it doesn't matter what order I put these two middle terms right here. We could have put it minus 9y and minus 4y in a different order. We'll still get the same factorization because in the first pair of terms, 9y squared minus 4y, we factor out y, leaving us with 9y minus 4. In the second pair of terms, we would factor out negative 1, leaving us with positive 9y minus 4. So 9y minus 4 is our common binomial factor, leaving us with y minus 1 once that's factored out. This is the factored form we wanted, and so we're done.